Welcome to this session. Here we discuss about the problems on limits. So the first problem was to evaluate the limit of z squared minus 5z plus 10 as z approaches r1 plus I. Now this being a polynomial, we'll just use direct substitution to work out the limit. So solution, limit as z approaches 1 plus I of the function z squared minus 5z plus 10 will be given by, so replace directly 1 plus I squared minus 5 into 1 plus I plus 10. Let's go, this will be 1 minus 1 plus 2I minus 5 minus 5I plus 10. Now 1 minus 1 is 0, so minus 5 plus 10 is 5. 2I minus 5I is minus 3I. So the answer for that limit is 5 minus 3I. So that was the first problem. Command 2, what evaluate the limit. Roman 2, limit of the function z squared plus 1 divided by z power 6 plus 1 z approaches I. Now, one thing that you have to remember is that before you start applying any other method, try to check whether direct substitution can work or not. So if you are to do direct substitution, you'll have I squared plus 1 over I power 6 plus 1. And I squared is negative 1, so plus 1. And I power 6 is minus 1 plus 1. So we get 0 over 0 and defined expression. So that means direct substitution will not help us. But observe that this limit can be written as, or can be seen as, right, z squared plus 1 over this z power 6 can be written as z squared power 3, and then 1 can be written as 1 power 3. So we'll do factorization of this denominator using the expression a power 3, or using the identity a power 3 plus b power 3 is given by a plus b times a squared minus ab plus b squared. So this is factorization of a cubed plus b cubed. So in our case, we have z cubed, z squared power 3 plus 1 power 3. So our a is z squared, our b is 1. So z squared you get z power 4. And then minus 1 times z squared is z squared. 1 squared is 1. So it means this denominator can be written as a product of these two terms, so that we say this is the same as limit as z approaches I of, now the numerator remains to be z squared plus 1. Denominator is z squared plus 1 multiplied by z power 4 minus z squared plus 1. So with this, we see that this term and this term of this bracket and this bracket cancels out. So we'll have limit as z approaches I of 1 over z power 4 minus z squared plus 1. And then direct substitution will give us 1 over I power 4 minus I squared, then plus 1. So I power 4 is 1 minus I squared is minus 1 and then plus 1. So minus minus is plus, so it'll be 1 plus 1 plus 1. So which gives 1 over 3 as the solution for that given limit. And then Roman 3, the problem was limit as z approaches pi over 4 of the function cosine of 2z over hyperbolic cosine of iz, and then plus I hyperbolic sine of iz. So for us to work out this value, you should confirm that when you replace pi over 4 into this expression, you'll get 0 over 0. So it means that now you need to do some factorization for this given function before you evaluate the limit. Now, solution, we know that hyperbolic cosine of iz is the same as cosine of z. And then hyperbolic sine of iz is given by I sine z. And cos of 2z is the same as cos of z plus z, which is the same as cos squared z minus sine squared z, double angle for cos function. So that means that our limit as z approaches pi over 4 will be written as, so numerator will be now cos squared z minus sine squared z divided by, so hyperbolic cosine of iz will be replaced by cos of z plus I, then hyperbolic sine of iz will be replaced by I sine z. So this will be limit as z approaches pi over 4 of cos squared z minus sine squared z divided by, so I times I is I squared whose value is -1. So we have cos z minus now sine of z. And then cos squared z minus sine squared z is a difference of two squares. So this limit as z approaches pi over 4 of the function. Now I write this one as cos of z minus sine of z. I multiply by cos of z plus sine of z. And then I divide by cos of z minus sine of z. Now with that factorization, you see that this bracket and this bracket cancels out. So which will give us limit z approaches pi over 4 of now cos z plus sine of z. Now direct substitution will give us cosine of pi over 4 plus sine of pi over 4. Cosine of pi over 4 is 1 over root 2 plus sine of pi over 4 is also 1 over root 2. So it will give us 2 root 2. Now you can rationalize by multiplying by root 2 by root 2. You have 2 root 2 over 2, whose value is just root 2. Because this one cancels 1, this one cancels 1. So therefore, the value of that given limit is given by square root of 2. That's how we solve that. And lastly, we had the limit, part 4, limit as z approaches I of z squared minus 1 over z power 6 minus 1. Now remember, a cubed minus b cubed is given by a minus b multiplied by a squared plus ab plus b squared. This identity is going to help us to factorize this, because once you try to do direct substitution, you'll get a case of 0 over 0. So z power 6 minus 1 can be written as z squared power 3 minus 1 power 3. So it's like our a is z squared and our b is 1. So z power 6 minus 1 is equals to z squared minus 1 into, so when I square I get z power 4, then plus z squared, and then plus 1. So I'll write limit as z approaches I of z squared minus 1 divided by, so where is z power 6 minus 1, I replace by z squared minus 1 multiplied by z power 4 plus z squared plus 1. So with this, I cancel this and this one here, so that I get limit as z approaches I of 1 over z power 4 plus z squared, then plus 1. Direct substitution will give me 1 over I power 4 plus I squared plus 1. Now I power 4 is 1, I squared is minus 1, then plus 1. This will give me 1 as my final solution. So this is how we are supposed to carry out computations involving those 4 limits. Thank you.